Hey, Bogdanovski here, another video. Linear functions. What about slope? What is the meaning of the slope? We're going to talk about this in this video right now. So you probably have seen many different situations in life where you can visualize a straight line. A straight line or a line segment that has a certain direction. It goes somewhere, and this is very important for you to connect in mathematics, and I'm going to show you where people make mistakes when it comes to mathematical aspect of the slope. So grabbing this example, you see sort of a horizontal line, and then you see the steepness of the roof. There is a pitch, right? So those are the directions of a line where slope can be connected. You can visualize, for example, you've seen stairs in buildings, houses, places in the public. You see a certain pattern here. And we talked about patterns in another video talking about finite differences. The first difference was the same. The changes were constant. So this is the application or connection between a slope and the linear function and how to calculate that slope. You had a glimpse of that doing the first differences. You can visualize the situation: an object is flying up in the air, a drone in this example, and there is a line, the side of vision, that you can sort of imagine. And this particular line make a certain angle with the ground level, and the angle represents the ratio, the vertical divided by the horizontal number, and that implies also the value of the slopes in mathematics. Some of you already driving, or you will be traveling somewhere, you have seen warning signs, steep hill, and oftentimes they give you the percent value, so they implicate that there is a gradient of sort. There is a slope that is for you to be aware of when you're driving, right? So there is a certain direction of steepness, certain value. So in the slope vocabulary, you see words like this: incline, decline, steady growth, steady sort of decrease in values, gradient, pitch, tilt, etc., ramp, and so on. And in mathematics, when you do the translation into mathematics, the slope coefficient will be the one that is mostly used. Then rate of change, right? How many kilometers per hour? How many liters per minute? Rise over run ratio. So the rate of change represents the ratio, so that's the rise over run. The gradient, the unit rate, right? 50 miles per hour. Steepness of a line, positive or negative, you're going to see that. So in mathematical word, the linear functions and the meaning of slope pretty much represents the steepness of a line, a straight line in the Cartesian plane always makes an angle with x and y axis, right? The x-axis angle and the line really is connecting the concept of the slope. Now, you may have a line directed upward or line directed downward, so the slope is either positive or negative in mathematics. Or horizontal line, the slope value is 0. But there is an important key for you to understand, that we always read the graph from left to right. That is the key here. Once you establish that this is the direction where you read a text in English language and in many languages that are based in Latin, you would be reading left to right. So in mathematics, consistently the same idea has been applied. So positive slope represents a line where x values are increasing from left to right, and the line has a tendency of going up, up, up. So in table of values, if you were to build table of values using points selected on this line, you will see that for every x value that is increasing, the y value is also increasing. In case of the negative slope, we again read from left to right. That is the direction. You scan the diagram left to right, and you observe that for each point that you select on the line, the y coordinates, the y value is decreasing. So in the process of calculation, you anticipate the slope value to be negative. And in this case, where the slope is 0, that simply means you scan again from left to right, you read this change, if there is a change on the graph, and you observe that for each x coordinate that is increasing, the y coordinate constantly remains the same. There you go. So hopefully that makes sense. Now, in the bigger context of linear functions that you will learn more and more, slope is the commonly used term. Slope and y-intercept, right? So this is sort of the big picture that you're encompassing as you're learning about slope of a line for now. You will be coming across most of the time situation where 2 points are given. So you have 2 points, there are separate points. Any 2 points define a straight line. You don't have to have more than that. 2 points would define unique direction of the line. And then between those 2 points that you create or position on Cartesian plane, you will be able to make the following observation. There's the x coordinate given, and there is a y coordinate given. As you scan the diagram from left to right, you see that there is a horizontal change from point A until you line up vertically with point B. So that's a horizontal change. So that's the difference between x coordinates. And then there is a vertical change. That is the difference between y coordinates. So you have to be able to always establish the following. The x coordinates are always first. For any point on Cartesian plane, x is the first number that you see. Y is the second number that you see. That's the order, that is the pattern. And once you know the horizontal change, once you know what is the vertical change, then you can build a slope which is simply the ratio. You divide those two differences, but always vertical change divided by horizontal change. Some lines would represent the negative slope. So instead of the rise that we used to call it, in case the line is rising up, you can call it negative rise or you can call it a fall. So this change here, the vertical change represents the negative number, because when you do the difference between coordinates, you will see that the number is negative. So when you're starting at point A and end up at point B, so you do the first differences. Do you remember the tables that we did in previous video? We did the second coordinate minus the first coordinate. So 2 minus 10 will give you negative reading. The RAN value always is positive because as we move along x-axis from left to right, that is the direction that you always maintain. You never change that. Then the values on x-axis are increasing to the right. So 5 minus 1 obviously would give you positive results. So whether you have falling down line direction, the slope is negative, or you have a line that is increasing, rising as you scan from left to right, the slope would be the ratio of that difference in y coordinates, which is called rise, or the difference divided by the difference between x coordinates, which is called run. So let's dive in. Knowing that this is the ratio rise over run, so our goal is to establish how do you calculate this distance and how do you calculate that horizontal distance. So if I grab a little dot right here, I'm going to emphasize the following, that the horizontal distance is from the first coordinate of the first point to the second x coordinate of the second point. The rise or the fall, if you will, depending on the direction of the line, it is from the first point to the second point, but the difference is second minus first. Second minus first for the run as well. So this is the formula. This is the formula that it is used to define the ratio, rise over run. So y over 2 minus y over 1. So the mistake that students tend to make, they do this. They think that y1, and they put 1 as an exponent, and they put y2, and this is y squared. So this is something that you have to become aware of, that this is a big no, right? So this is wrong idea to think of it as if this was an exponent. That small subscript just makes a distinction between two different values, whether this is x value or y value. Just be aware of that, because this is very common mistake. The second common mistake students make when they switch around, instead of going y2 minus y1 divided by x2 minus x1, sometimes kids do x1 minus x2 at the bottom, and the top is y2 minus y1. You have to understand, you have to be consistent, because truly there is no first point really or second point, because you can call it this one as your first point and this is the second point, so that you could change the order in which you subtract. You can go y1 minus y2 divided by x1 minus x2. See, I use that consistently. If I go y2 minus y1 on top, I have to go x2 minus x1. So this is the mistake that is commonly used by students, especially when they don't get this concept straight right from the beginning. So in this beautiful example, point A has coordinates 1 and 2, right? So this would be point A right here with coordinates 1 and 2. And then point B would be here. So our goal is to find the ratio between the rise and run values. So good idea, always a good idea as you're learning, is to label. Let this be x1, so then this coordinate is y1. If you choose A to be the first, then obviously the other point will be the second. So this is x2, the x coordinate, and the second coordinate 10 is y2. Knowing that you have labeled, you organize your coordinates, you can proceed to the formula and use it the way you have labeled coordinates of your points. So the first thing you always do, label coordinates, and then you proceed with the application of the slope formula. So that is why 10 minus 2, because 10 is the second, 2 is the first y value, divided by 5 minus 1, because 5 is x2 and 1 is x1. So 8 minus 10 minus 2 is 8 on top. 5 minus 1 is 4. So this is the ratio. 8 over 4. When you simplify, this is 2. So this is also, you can see it, 2 over 1 ratio. Every time you go 1 unit to the right, you go 2 units up. You would build the stairs, 1 to the right, 2 units up. So that is the rate of increase. The slope is positive. So now you understand the line that you're representing by those 2 points must be increasing, must be rising from left to right, because the slope is positive. Now, if you change coordinates, for example, randomly selected change, now point A is at 1 and 10, so technically on the grid it is first, and then B is the second. So point A has a higher y value, point B has a lower y value, so there's a downward trend. So the line should be declining, decreasing, because the slope, when we calculate, will be negative. So first thing you do, you always label your coordinates. Identify what is your x1, what is your y1. It doesn't matter which one is first, which one is second, really. But as long as you label it and you recall the formula for this ratio of the slope, you always find. You have to be consistent. So the first point, second point, for example. And then the formula, right? And then the proper substitution. So 2 comes first, then the tan value, divided by 5 minus 1. And then you calculate each part separately. 2 minus 10 is negative 8. 5 minus 1 is 4. So hopefully this makes sense. So negative 8 divided by 4 gives you negative 2. So now you understand why the slope is negative, what that really means. That means that the line is decreasing, that the slope shows the decline, constant rate of change downwards. This was constant rate of change upwards because of positive slope. If the slope is negative, then line is declining, positive slope, line is increasing. If the slope happens to be 0, then you would have identical y values for any 2 points, and the numerator will be 0, so the ratio will be 0. Now, there are sometimes cases where the line is not a function, a vertical line case where the slope does not exist. So this is the situation where the slope is undefined, and we'll be talking about it a little bit later. But for now, you understand that there are 3 main signs of every linear function slope: positive, 0, or negative. So hopefully this makes sense now. We're ending this video with a beautiful practice question. And at this point, I understand and you know that you know much more about slope of a linear function. And go do the questions, and we'll see you in the next video. Thanks for watching. Bye for now.